Hello class, this is a video tutorial on index laws part 1. In this video we'll be looking at the addition and subtraction of indices. When multiplying terms with the same base, their indices will add. So here we have, if you have m to the power of a times m to the power of b, the two bases are the same. Therefore, their indices will add. When dividing terms with the same base, their indices subtract. So, same example here. Both have the same base. They're being divided. A and B. You could actually rewrite this as a fraction. M to the power of A over M to the power of B. These two expressions mean the same thing. But ultimately, the main point that we're trying to get across here is that it's going to be a, so this power, take away the denominator power. So let's simplify the following. You can go ahead, pause the video and give it a go yourself. So here we go. If we have a expression without an index, it's assumed to have a power of 1. So a times a simply becomes a squared, because the two indices 1 and 1 will add. Same case here. I can show you the extended version where you could write the following. You can write that. Sometimes you'll find it useful to do so, but in the end, it's just the two indices adding. If we have an expression being multiplied and they have the same base, so this just becomes b to the power of 5. Even with a group such as this, when you multiply it out like this, it'll become equal to 2. This is c to the power of 1, c to the power of 2. They have the same base, therefore the indices will add, c to the power of 3. And we've seen something like this before. This just becomes c squared times 3x. Well, there are no indices that can add, so we just write it in alphabetical order, 3c squared x. Now I'd like to point out, since we're here, when you write your indices with multiple terms in them, don't be shy to give the indices plenty of spaces. I've seen this done in the past, and it's really poor practice. You don't know exactly where that power belongs, so it's always best to write it with plenty of space, so 3c squared x, and give it plenty of space there. Here we are, with multiple terms in the same expression. For this, we just focus on the numbers first. So 4 times 2 is 8. D squared times D. Those indices add, so there's a 2, and there's a 1 here. So those add to become D to the power of 3. And likewise, E times E to the power of 4. Those indices also add. There's a 1 here, so it's going to become e to the power of 5. Let's move to a harder examples now. These are division. For this, they have the same base and it's being divided. It's f to the power of 5 take away 3. It's f squared. Even with this, we have numbers dividing first. So 12 divided by 4 is going to be 3. G to the power of 4, so it's going to be a G here, and it's going to be 4 take away the 1, so that's going to be G to the power of 3. Here's where it gets a lot harder now, when you have expressions with many terms and a fraction instead. Focusing on just the numbers, you can look at this as just a fraction right now. So 15 divided by 3. We want to simplify that by dividing the numerator and the denominator by the same number. So 15 can be divided by 3. 15 divided by 3 is 5. 3 divided by 3 is 1. Focusing on the next pronumeral, h to the power of 8 divided by h to the power of 2. That's going to be h to the power of 6, and the numerator is larger, hence why it's going to be h to the power of 6 in the numerator. I to the power of 7 divided by I to the power of 3. That's 7, take away the 3. It's I to the power of 4. So really, there's nothing left in the numerator, because we don't need to write or leave this 1 here, so we could just remove it and just leave our expression like so. One last example. Once again, just focusing on one expression at a time. So 18 divided by 6. 18 divided by 6, that's just 3 over, well, actually what happened is 18 divided by 6 is 3. 6 divided by 6 is 1. So we still have the fraction, it's just that I simplified 18 and 6. J to the power of 7 divided by j, that is 7, take away the 1 that isn't written. So 7 take away 1 is j to the power of 6. K to the power of 4 divided by k to the power of 7. That's 4 take away 7, which is negative 3. But you'll soon learn that negative indices belong in the denominator like so. Another way you could simply think about this is there are more k on the denominator than there are k's in the numerator. So we can cancel as many as we can, but there will be 3 remaining in the denominator. So in the end, let's just make this neater. We have 3j to the power of 6, 6 over k cubed. So I hope that gave you an insight into the addition and subtraction of indices with the same bases. So hope to see you in the next video. Best of luck.